Okay, so let's do a little bit of algebra. 1/3 x plus 2/5 equals 3/4. It might be shrewd here to get rid of the fractions. So that's the process I'm going to go over right now. First thing you want to do is find the LCD. It's the lowest common denominator. The best route to get rid of these fractions might be to go the LCD route. Or to solve the problem, rather. You could solve the problem by subtracting 2/5 on both sides, finding the LCD of 4 and 5, getting both fractions where their denominators are the same, finding a result, and then multiplying the whole thing by 3. That's a pretty good route. We're going to do both routes back to back. So let's do it. Let's do the LCD. All right, so right now, these numbers are really close, 3, 4, and 5. So I can almost guarantee that the LCD is going to be 5 times 4 times 3. Normally, you want to look at the biggest number, right, 5, and just check and see if these two go in evenly or not, and then go to 10, and then 15, and then 20. Just double, and then triple, quadruple, and then keep checking, keep checking. But because these digits are so close, and there's 3 of them, it makes it pretty obvious that our LCD is going to be 60. And it actually does end up being 60. So just something that you'll learn. Just keep, getting out there, playing with numbers, as I like to say, and you'll start to spot patterns. You'll start to sort of figure stuff out. Like, oh, this is interesting. When, the numbers are all bunched up and there's at least 3 of them, I know that I'm going to have to find the LCD, I'm going to have to multiply 3 times 4 times 5 anyways, right? So, etc. So, all right, so here's what we're going to do. Parenthesize this. Multiply by 60. Not just 60, though. 60 over 1 is what I recommend. Now, here's a step that I think is really important, and not everyone does. First of all, I like to line everything up. I like to put the fractions, not like in a weird, wonky way, but like just, horizontal line, fraction line, right? Easy to see the numerators, easy to see the denominators, easy to do math, right? Plus times a plus. The other thing you could do is you could actually draw little lines between 60 and the 3 terms. So this becomes a factor. This parenthesis becomes a factor. These are 3 separate terms of the factor. So now you have 3 terms. So plus times plus is plus. And then you could bring down 60 over 1 times 2/5. And then what is oftentimes forgotten on math students' papers, I'm sure I forgot it here and there when I was coming up, but I learned you want to protect yourself from yourself, right? So the way you protect yourself from yourself a lot of times is to write this stuff out. Like do this, these long arrows, and you have 3. So you're going to have 3 60s, 60, 60, and 60. And you're multiplying it by 3 separate terms, right? Now, after you've done this for a while, you won't have to do this anymore. You really won't. You'll just know it, and you might not even have to do this anymore, like write this step out anymore. But I would say to start out doing all this stuff, get really good at it, and then you can sort of truncate your written out steps. So this is 1, this is 20. I usually do all the math first, and then I bring everything down. So 5 divided by 5 is 1. 60 divided by 5 is 12. 4 divided by 4 is 1. 60 divided by 4 is 15. So remember, they're all going to be 1s in your denominator, right? That's what we're doing. That's our goal. Our goal with creating this multiplier here and distributing it is that we're getting rid of all of our denominators, so making it easier, ideally easier to do the math. Oh, here, I forgot the x. To do the math. So you got 20 x plus 12 times 2, right? 24 equals 15 times 3 is 45. right? Minus 24, minus 24. That's 21. Divide both sides by 20. You could put 1 and 1/20. However, unless you need to use that mixed number for something, usually as a display, right? Unless it's something where the question asks you to put everything in mixed number form, you generally want to keep it in improper fraction form. The reason why is you might use that number later. It's just good practice, right? You might use this, and it's much easier to use an improper fraction than it is to use a mixed number. If you were going to use that mixed number, it's pretty strong thought that you're going to have to turn it into an improper fraction anyways. If you need to multiply by another improper mixed number, for example, or improper fraction for that matter, you're going to have to translate it anyways. You're going to have to move it. So I would make all your answers a reduced form of an improper fraction and box it or circle it unless the actual problem talks about specific items, or unless it's if it's asked for, a mixed number is asked for in the answer. So, you're not going to say, Jordana had, 21/20 glasses of juice in the fridge, period. You're going to say Jordana had 1 and 1/20 glasses of juice in the fridge, or ounces of juice in the fridge. So it's got to sort of make sense, got to flow. But generally, if it's only the values that you're looking at, then you generally want to make the choice to have your answers be in the reduced form of an improper fraction as opposed to a mixed number. But yeah, hopefully the LCD step or the sort of route is helpful. I actually really like this route because I don't like fractions in standard algebra problems. So right when I see the fractions, I say, all right, let's get rid of the fractions. Let's find the LCD, get rid of the fractions, and do the math computation.